Okay, now I'm going to work through some examples, guide you through some examples without providing all the details of solving polynomial inequalities using a sign chart. And at the end of each problem, I will give you the answer so you can check your work. Okay, so the first problem, actually the directions for both problems will just be solve. Let's use a different color here. Solve. And I want you to solve x to the fourth times x plus 5 times x plus 3 squared is less than 0. Okay? Now to get started, because luckily this is factored and one side is 0, all we have to do are two things. The first thing, let's say, is let's name this polynomial that's on the left, let's name it as y. Okay, so we're basically trying to solve when y is less than 0. Okay, so we're going to set up a number line chart for our x values. And what I want you to do is cut your number line at the 3 zeros of the polynomial. Okay, so see if you can figure out the 3 zeros and cut your number line at those zeros. And while you're at it, go ahead and identify the multiplicity of each of those zeros. We'll need to know those to be able to determine if the signs change as we work through the number line chart. Okay? So once you've got your zeros and multiplicities, go ahead and label y above your number line chart. And then for each of those x values that you've cut, those specific 3 x values, plug them into the function that you've called y. Plug each of them in independently. So for example, whatever this x value is, plug it in for all 3 x's, multiply all of this out, and see what you get for your y value. So then put your y value for each of the zeros up here. You may need to pause the video while you work that out. Once you've got the y values for the 3 specific x values you've got listed, now what I want you to do is figure out the sign, the plus or minus on each end. So the plus or minus for the y values. The way to do that is to take your polynomial, identify your leading term. So see if you can identify the leading term. And remember, since this is factored, you have to imagine if you were to multiply all of this out, what the first term would be. So it's x to some power. Okay, I'll give you a hint there. So see if you can figure that out. Sorry the screen's jumping around a little bit here. Once you got your leading term, pause if you don't and figure that out. But once you have your leading term, identify your end behavior, whether the right end goes up or down, the left end goes up or down, and then use the right end of your graph to determine the right sign, and the left end of your graph to determine the left sign. Okay? Once you've got those, use your multiplicities to determine if the signs are the same or different across each of those zeros. Okay? So identify whether these are the same or different. And then once you know those, go ahead and fill in all the signs in between your zeros. Pause to complete this number line chart if you need to, but when you come back, you should have a complete number line chart. Now, once your number line chart's completed, put a check mark next to all the signs, which signs here for y values, which ones have y values that are less than 0. In other words, where y values are negative. They can't equal 0 and they can't be positive. So put check marks next to those and put x's through the ones that aren't less than 0. Once you know where all the places where y is less than 0, shade the corresponding piece on the number line chart below. Okay? Figure figure out the x values where that happens. Then, once you got your number line chart shaded, all the x values shaded, convert that to interval notation, and that will be the solution to the problem. Okay? So pause the video, rewind if you need to, see if you can get all that done, and when you come back, I'll give you the answer so that you can check your work. So the correct answer in interval notation is negative infinity to negative 5, not including negative 5, and there's no other interval that works, so you don't have any unions. Okay, so that's it. Negative infinity to negative 5, not including negative 5. That's indicated with a parenthesis. Okay, good. So if you didn't get that, keep rewinding, keep working through it, making corrections until you get it. When you're done, come back and work the second problem that I'm going to do. The second problem is again solve, and this one is x cubed minus 9x is greater than or equal to 6x squared minus 54. Okay, this one's a little more involved because the first thing we need to do is we need 0 on one side, and then we're going to have to factor the other side. So to get 0 on one side, what I want you to do is get rid of this stuff on the right. So so basically subtract 6x squared and add 54 to both sides. And make sure that when you rewrite the left side, it's in descending order. Okay? And on the right side, you should have greater than or equal to 0 at that point, once you've gotten rid of the stuff on the right. Then what I want you to do is you're going to have 4 terms here that you need to factor. Okay, I'm not going to show you how to factor it on your own. But I'll give you a hint that since it has 4 terms, I'll tell you to factor using grouping, if you know that technique. Or if you use any other technique, go for it. But basically you need to factor. So after you factor, pause if you need to catch up, but after you factor, you should have 3 factors multiplied together to be greater than or equal to 0. Now you're at the same starting point as the first example. Now that it's factored, go ahead and set up your number line chart for x values and cut it at each 0. You should have 3 zeros here. Cut it at those and go ahead and identify the multiplicities of each. Then what we're going to do is we're going to think of this left side as y. We're going to give it a name, so we're trying to figure out when y is greater than or equal to 0. So let's list y above our number line and go ahead and determine the y values for each of these 3 particular x values. Okay? Then you need the signs in between each of those. So determine your leading term and then use it to take a look at your end behavior on the left and the right. Once you've got your end behavior, your left and right ends, fill in your signs on your number line chart for the y values on the ends. Then, using your multiplicities, determine if the signs here across each 0 are same or different, and then fill in. So you've got your end signs. Use your multiplicities to get your middle signs. Then finally, to finish off, we want to know where y is greater than or equal to 0. So go through and look at each of the y values here, right? Each y value. And put a check mark next to those that are greater than 0, so that means positive, or equal to 0. So if they're equal to 0, put a check mark also. For ones that aren't positive or equal to 0, cross them out, put an X through them. Then once you've figured out all the places where y is greater than or equal to 0, all the ones with the check marks, shade the corresponding x values on the number line, either the regions or the zeros. Once you have your shading done, go ahead and convert it to interval notation to get all the x values that make the original inequality true. So you may pause the video, work back through all this, make sure you're completely done, and then come back and I'll give you the answer. Okay, you should have worked it all out. The correct answer is bracket -3, comma, +3, bracket, union, bracket 6, comma, infinity, parenthesis. Okay? So you see some of the endpoints of the intervals are included this time, so make sure you got that right and you understand. If you didn't get it right, go back through and rework until you're able to figure it out.